PB3 Powerboy. The American company Ocean Power Technologies has developed an interesting solution to provide electricity to objects at sea. The PB3 Powerboy, or Power Buoy, is an uninterruptible power supply that uses the kinetic energy of waves to generate electricity. The advantage of the PB3 Powerboy is its extreme flexibility. It can operate in depths from 65 to 10,000 feet. It provides an uninterrupted supply of power, and it can store surplus electricity. In addition, the PB3 Powerboy communicates with remote objects on shore and is able to transmit various data in real time. Turbulent hydro turbine. This is a development from Belgium. It's a much more economical and affordable alternative to large, expensive hydroelectric power plants. The whirlpool turbine is installed on a river or canal with running water, in a place with a small elevation difference. The installation takes exactly 1 week, after which the plant generates electricity all day, regardless of the weather. Electricity is generated by whirlpools that occur naturally inside the concrete turbine. The capacity ranges from 15 to 70 kilowatts, which is enough to supply power to 6 or 7 homes. And since the turbine can be installed in close proximity to them, money is saved on transporting electricity. The turbine is absolutely safe for fish and other animals, and its service life exceeds 100 years. Orbital O2. The construction of this 240-foot, 680-ton turbine began in 2019. It wasn't until July 2021 that it was finally put into operation in the Orkney Islands. Orbital O2 from Orbital Marine Power is currently the world's most powerful tidal turbine. It generates about 2 million watts of electricity, enough to power up to 2,000 homes all year round. Its bidirectional turbines generate electricity both at low and high tides. This energy is considered green, so Orbital O2 will also reduce humanity's carbon footprint by 2,200 tons each year. Open Hydro Tidal Turbine. This is the largest tidal power plant in North America, which was put into operation in November 2016. It's a joint project of the Irish company Open Hydro and the Canadian company Emera. The plant is located off the coast of Canada, and it generates electricity for Nova Scotia. The structure is striking in its scale. It stretches to the height of a 5-story building and weighs about 1,000 tons. According to the idea, its final capacity should be 16 megawatts, which is enough to fully meet the electricity needs of a small town. Notably, this is not the first open hydro project. A little earlier, they put into operation an open center turbine that was lowered into the water by 2 15-ton hydraulic winches. The Wavestar machine. An ambitious project to unlock the energy potential of the ocean was presented several years ago by the Danish company Wavestar. Their innovative hydroelectric power plant consists of many individual modules. Each will have 20 floats with a diameter of 16 feet. As they move along with the waves, they activate hydraulic mechanisms that turn the shaft of the generator, thereby producing electricity. At the moment, however, the project is still under development. Engineers are now testing a prototype with only a couple of floats. It was installed in the northwest coast of the North Sea at a depth of 23 feet, and it already generates up to 500 kilowatts. Landestry Hydropower Screw. A mini hydroelectric power plant, similar to another model already shown today, was presented by the Dutch company Landestry. This is a screw hydro unit, which is installed in channels with a difference in elevation. High efficiency is achieved even if the difference is only 3 feet and the water flow is 132 gallons per second. The design is easy to install, it requires low maintenance, and it's compact and durable. It generates power continuously, regardless of the time of day or season. In addition, the unit is clog-resistant and safe for fish. UniWave 200. The video shows the construction of a pneumatic wave energy generator, which began operating earlier this year in Australia. The project was developed by the company Waveswell Energy. The construction is experimental, but it has already reached a capacity of 200 kilowatts. If the tests are successful, the company plans to build a larger and more powerful version of the power plant. The operating principle of UniWave 200 is worthy of special attention because the system doesn't use low and high tides to generate electricity. Instead, it imitates a whale's blowhole. Waves run into the concrete chamber, forcing the air inside it into a special channel. Inside there is a wind turbine which generates energy by rotating. Water rotor. No complicated construction work is needed to install this mini power plant. That's because water rotor is a revolutionary patented technology that extracts energy from slow-moving water sources like streams, rivers, canals, and underwater ocean currents. The speed of the water may not even exceed 2 miles per hour, but that's enough to generate from 1 kilowatt to 1 megawatt of electricity, depending on the model. The units are portable, compact, and a truck can transport up to 20 units. Unlike other sources of alternative energy, they generate electricity all day, all year round. And of course, water rotors are safe for flora and fauna. Stream. The following mini hydroelectric power plant was developed in Japan. The peculiarity of Stream is that it can operate even in conditions of extremely low water pressure. It can be installed in agricultural irrigation canals, water treatment facilities, and small channels. Thanks to its compact size, Stream can operate even in cramped conditions. Other noteworthy features are the ease of installation, which can be completed in 2 days, the ease of maintenance, and low off-time operation. According to experts, Stream operates from 85 to 90% of the time a year. The output power range ranges from 0.5 to 44 kilowatts. Tom Sauk. This hydroelectric power plant is located in Missouri, USA, and its main feature is that there are no natural water sources nearby. Water is specially pumped into the reservoir. Electricity is generated as follows. Water from the main reservoir is released through turbines into the lower reservoir, located 1.2 miles away. This procedure is carried out during the day to meet daytime peak electric power demand. At night, the excess energy is used to return the water back to the mountain top to the main reservoir. There are power plants like Tom Sauk all over the world, but this is the largest of them all. Micro hydro turbine system. Similar units can be found in many areas of Indonesia, Vietnam, the Philippines, and Myanmar. Anliatech Energy installs them. Micro hydro turbines are compact and therefore easy to install in rivers and irrigation canals. The capacity varies from 2 to 50 kilowatts. At a time when human consumption of electricity is increasing by the day, even one of these units can be invaluable. Most often they generate power for small remote settlements. Lunar Seawork 2. Let's check on one of the most important infrastructure projects in Austria in the coming decades. This is a pumped storage power plant, which will have a capacity of 1,000 megawatts. Construction is scheduled to start in 2022. This will be the largest pumped storage power plant in Austria, so construction work is not expected to be completed until 2037. A total of $2.2 billion has already been allocated for the project. Interestingly, most of the pipes, tunnels, and even the power plant itself are all located underground. According to the project, they'll be located inside the mountain.